Hello everyone. So this is a question from JEE Mains 2026, 8th April Shift 2. Which of the following statements are not correct? Okay, so I will underline this, not correct. Okay. So statement A, for water, magnitude of KB is greater than magnitude of KF. Okay, so we are talking about water here and KB and KF. Okay. So let us look into statements one by one. So regarding statement A, and yeah, the chapters involved is solutions. Okay, so kb is the molal elevation constant. So regarding statement A, we know that kb is known as molal elevation constant. It is also known as ebullioscopic constant. Ebullioscopic constant. And always remember, kb is always calculated for the solvent. Okay, it is always a value for the solvent. It does not make any sense for the solute. We always calculate kb for solvent. Okay, so its unit is Kelvin kg mole inverse. And for water, if you are using water as a solvent, its value is, for water, kb is 0.52. Okay, similarly we have kf. Kf is known as the molal depression constant. Molal depression constant. It is also known as cryoscopic constant. Cryoscopic constant. So these names are important. Okay, obviously it is also for the solvent. Okay, it always makes sense for the solvent. Its unit is the same, Kelvin kg mole inverse. And for water, its value is 1.86. Okay, for water, kf is equal to 1.86, right? So what is statement A saying? Statement A is saying value of kb for water is more than value of kf. No, for water kb is 0.52 and for water kf is 1.86. So this statement is incorrect. So statement A is incorrect. Okay, so I will write down the statement that statement A is not correct. Okay, cool. So let us look into statement B. Okay, the elevation in boiling point of water when a non-volatile solute is added to it is larger in magnitude than its depression in freezing point. Okay, so we are talking about elevation in boiling point and we are talking about depression in the freezing point. Okay, so let us say that for statement B, let us say that we are adding, so when we add certain amount of non-volatile solute to water, the elevation in boiling point will be obviously delta Tb, right? Where delta Tb is Tb minus Tb naught. What is this Tb? Tb is the boiling point of the solution and Tb naught is the boiling point of solvent, right? So in our case, the solvent is water. Cool. So we know that delta Tb is equal to Kb into m, right? Where this Kb is the molal elevation constant or the ebullioscopic constant. And we know that the solvent now we are using is water. So we can write this statement as 0.52 into m. And this m is the molality of the solution, right? So we have added certain amount of non-volatile solute. And so let's keep it as m itself. Okay, so therefore the delta Tb when we add certain amount of non-volatile solute to water is 0.52 m, right? So we are adding similar amount of non-volatile solute and this time we have to talk about the depression in the freezing point, which is delta Tf. Okay, so remember the point, similar amount of non-volatile solute is added. So delta Tf is, again we know that Tf naught minus Tf. What is this Tf naught? Tf naught is freezing point of solvent. In this case, we have water. And Tf is freezing point of solution. Cool. So we know that delta Tf is equal to Kf into m, right? Where Kf is the molar depression constant, or the cryoscopic constant of the solvent. Solvent here again we have taken it as water. So therefore, and we know Kf for water is 1.86, right? So we can replace this value of Kf as 1.86 m, right? And obviously m in the previous case and m in this case will remain same, because we have added similar amount of non-volatile solute. So therefore molality of the solution will be same. So therefore, can you see delta Tb in magnitude is greater than delta Tf. So let's look at statement B. What is it saying? Statement B is saying that the elevation in boiling point, that is delta Tb, is larger, that is greater than delta Tf, which is not the correct statement. We just calculated that delta Tf is delta Tf is 1.86 m and delta Tb is 0.52 m. So therefore delta Tf is greater than delta Tb. So this is what we got, and our statement is saying that delta Tb is greater than delta Tf. Okay, so therefore statement B is also incorrect. So I will write it down. Statement B is also not correct. Okay, cool. Let's talk about statement C. So statement C is saying that osmotic pressure measurement is preferred over any other colligative property to determine molar mass of proteins and polymers. Okay, so there are 4 colligative properties that we know about. That is relative lowering of vapor pressure, osmotic pressure, elevation of boiling point, depression of freezing point. Okay, for determination of molecular mass of proteins, polymers and other macromolecules, osmotic pressure is the most suitable method. So this is a correct statement. Okay, so I will write it down. I will write it down that for determination of molecular mass of proteins, polymers and other macromolecules, osmotic pressure is the most suitable method. So this is a correct statement. So we would like to know the reason behind this. Okay, and why can't we use other colligative properties, for example elevation in boiling point or depression in freezing point? Why can't we use them for determination of molecular mass of proteins and polymers? Okay, so the first reason is that the changes observed in the other properties, for example elevation in boiling point or depression in freezing point, are very small. Okay, since that is, for example delta Tb or the delta Tf values that we calculate for these macromolecules like proteins, polymers and other macromolecules, this is very, very small, so it is difficult to record them. Okay, for example, I'll give an example. So 0.00001 Kelvin. So the value of delta Tb or delta Tf is this for substances having molar mass of order of 10 to the power 6 gram per mole. So you can see here for other colligative properties like elevation in boiling point or depression in freezing point, their change, that is the colligative property, is very, very small. The change is very, very small, so it is difficult to record, and it is so small for macromolecule of mass 10 power 6 gram per mole, right? But osmotic pressure of order of 10 power minus 3 atm can be easily measured in terms of mm. Okay, but osmotic pressure of order of 10 power minus 3 atm can be easily measured. Okay, the second reason is elevation in boiling point method for biomolecules like proteins are not suitable because these molecules are not stable at high temperature. If you remember, whenever you have to calculate elevation in boiling point, we have to reach their boiling point, and for macromolecules they are not stable at high temperature. Okay, so macromolecules are not stable at high temperature. So therefore, obviously, elevation in boiling point method is ruled out. But the advantage of osmotic pressure is that it can be measured even at room temperature. Pi can be measured even at room temperature, right? So therefore, we don't have to reach their boiling point. Every calculation can be made at room temperature, right? And the third reason is osmotic pressure uses molarity instead of molality. That is pi. In the formula, you can see CRT, where C is calculated in terms of molarity. But if you look at other colligative properties, for example, delta TB or delta TF, they involve molality, right? So this is the advantage of using molarity. The advantage is we can measure volume of solution easily using measuring cylinders, but so therefore molarity can be calculated easily. But mass of solvent in already prepared solution is difficult to measure, so it will be tough to measure molality, right? So therefore statement C is correct. So statement C is osmotic pressure is preferred over any other colligative property to determine molar mass of protein and polymer. It's a correct statement. Okay, so C is also correct. Okay, and the last statement, that is statement D. So let us look at statement D. The dimerized form of benzoic acid in benzene is this. Okay, so let us talk about this. Carboxylic acids, for example, acetic acid or benzoic acid, whenever they are dissolved in non-aqueous solvents, for example benzene, they exist as doubly associated molecules. Okay, so this is very important. Carboxylic acids, when dissolved in non-aqueous solvent like benzene, exist as doubly associated molecules, which are also known as dimer, okay, due to hydrogen bonding. Okay, and in this case, since they are asking for benzoic acid, so I will represent how do they form dimer. So obviously benzoic acid will have C6H5 COOH. So this is the benzene ring. Then we will have C, which is connected to a double bond O, carbonyl O, and OH, hydroxyl OH. Then we will have one more benzoic acid molecule. Since it is forming a dimer, it will have C. This is the hydroxyl OH and this is the carbonyl CO, and there is hydrogen bond between them, right? So this is how two molecules they associate and due to hydrogen bonds, and they exist in the form of a dimer. So this is what is known as association, right? So in statement D, let us see how have they shown the dimer. In this case, they have shown the dimer in this way, that is OH and O, which is not correct. Okay, this is incorrect. Statement D is incorrect. So they exist in dimer form in this way. So there are two hydrogen bonds. Okay, so I will write it down. So D is also incorrect, right? So in the question, they are asking us which of the following statements are not correct. Okay, so obviously A is not correct, B is also not correct, C is correct, and D is also incorrect. So the answer will be A, B, and D. Okay, thank you.